Alright, let's look at the homework 4.1, problem number 8. Alright, so we want to find the critical numbers and the interval of increase and decrease, and also local extrema. Alright, so let's do that. Alright, so in order to find a critical number, we need to find the derivative. So let's take the derivative. So f prime of x is equal to, alright, so this is, let's apply the quotient rule. And the square the bottom guy, so x minus 9 quantity squared. Derivative of the top is 2x, and times the bottom guy is x minus 9 minus, right, you have x squared and multiplied by derivative of the bottom guy, which is just 1. Alright, so if you clean that up, you're going to get, let's see, 2x squared minus x squared would be just x squared. And a minus, right, 2x times 9 is 18x. And over, same denominator, so x minus 9 squared. So this is equal to, right, I'm going to factor out x. We get x minus 18 all over quantity x minus 9 squared, and set that equal to 0. Alright, so this will give us, let's see, so I'm going to set the numerator equal to 0, and we have a critical number, so x equals set at 0. Set this guy equal to 0, we get 18. Right, so these are the critical numbers. Right, so let's type that in. It's at 0 and 18. Right, got that. And we want the interval of increase and decrease. Let's draw a number line. Alright, and the first thing we do is let's look at the domain of this function. You can see that x equals 9 would be bad because it will make the denominator equal to 0. So domain of f is all real numbers except for 9. Alright, so I'm going to actually put 9 here right in the middle and indicate that we cannot have this number. So I'll just maybe put a open circle there. So 9 is excluded from the domain. Alright, then put a tick marks on 0, so that's a critical number here, and another critical number is 18. Alright, then we're gonna just try to see the sign of f prime, because this tells us about increasing decreasing behavior of the original function f. Alright, so we can just try any sample number less than 0, so I'll try -1. And between 0 and 9, I'll probably try 1. Between 9 and 18, I'll probably try, say, 10. Right? And anything bigger than 18, so I'll try 19 or something like that. Alright, so let's look at the sign. Alright, I'm going to focus on this guy right here. Right? And the denominator already have a square, so it's always non-negative, so we don't have to look at that. Alright, so let's look at the top. If you put the -1 for x, -1, so that's negative, and x minus 18 would be negative. Negative times negative is actually positive, so we put the positive sign here. Alright, and how about 1? So 1's positive, 1 minus 18 is negative, positive times negative is negative. Alright, same thing with the 10. 10 minus 18, so positive times negative is negative. And try 19. 19 is positive. 19 minus 18 is positive, so everyone's positive. Alright, so it looks like increasing on interval up to 0 and 18 and up. So let's type it in. Alright, increasing on negative infinity to 0. And what did I do? Alright, and here 18 and up. Alright, check the answer. So we got that. Alright, decreasing on, so everything else, so it's going to be from 0 to, so remember 9 should be excluded, so 9 to 18. Alright, so let's check the answer. Alright, we got that. Alright, so which statement regarding the local extrema function is true? Alright, so we have to determine local max and local min. Alright, so let's look at this. Alright, so first derivative test. So this is increasing. So if you look at f, on this interval, f is derivative positive, increasing. Here it's decreasing, and here it's still decreasing. Here it's increasing. Right? So it's easy to tell that here you're going to have, let's see, right here, you're going to have increasing turn into decreasing, so it's going to be a local maximum. Here decreasing and increasing, so this is going to be a local minimum. Alright, so let's type that in. Alright, local minimum at let's see, local maximum at 0 and local minimum at 18. So that's what we had, right? So I'm gonna just check there and check. Alright, we got that. Alright, that's it. I hope that this was clear.